Today we're going to do what's called compose functions, which simply means we're going to take one function and we're going to put the other function inside of it. And the x value is the x coordinate. So here is an example where they give you the two functions, but they give it in coordinates. So we're going to substitute each coordinate of x for g, and then substitute that in for f. So it's double substitution. So here's the first step. We have f of g, and the first x coordinate is 8. So I'm going to put the 8. Now, if you look at g of 8, we get 15. So we're going to, this whole part becomes the 15. Then if you look at the other function, where f is 15, right here, that equals 11. So the function of the first compose is 11. So let's do the next compose. I'm going to do another color. So if I go f, and the next g of 5, because that's the next x coordinate, g of 5 equals 1. So f of 1, if you look at the next function right here, gives us 8. So we get our answer of 8. Do the next function. The next function is the 10. So f of g of 10 equals, g of 10 equals 14. So it's f of 14. And f of 14 and the other function right here is 9. So basically everywhere we see an x value, we're going to substitute it into the function, and the y value is the answer to that function. And we'll do the last one here. The last function of f is of g, is 9. So the function of 9 is 0, so f of 0 is what we're looking at. We go back over here, f of 0 equals 13. So what we have is, this is the x, these are the y, often called the domain and range. So we have identified what's called the composition of f of g, and there's the domain and range. Now we're going to do the other composition, which is g of f of x. We're just composing g with f, putting f inside the function g. So now we're going to start with the start with the f function, and we look at the very first x, which is 1. And so we have that, and 1 equals 8. So it's the function of f of 1 equals 8, and now I put that into the g function. If I put it in the g function, I go over here, 8, I get 15. Now I'm going to do the next one, g of f. The next function is 0, so I'm going to put 0. And that gives us 13, so g of 13. And if we look over here, there's no 13. Since there's no 13, this is not defined, which means there's no answer. So now we'll do the next function, g, and I'm looking at the next coordinates. So f of 15. So f of 15 equals 11. So now we look g of 11 on the other side, and it's also not defined. And I'm going to do the last one we have here, which is f of 14. And so now I get g of 9, because that's what f of 14 equals. And g of 9 and the other function is 0. It does have an answer, 0. So our domain are these, because that's the x values, and our range are these two. So our range and our domain. Alright, the next type of composition is when we actually have a function. So here's what f of g means, g's inside. So we're substituting the function g. So all we're going to do is take whatever g f x equals and put it inside this function. So it's going to look right up here, f of, and g of x happens to be 4a. So I'm going to put 4a. And once I have that, I can then take this function and substitute it in wherever I see an a. So this becomes 2 times 4a minus 5. So there's the substitution of one function in another function, which gives us 8a minus 5. So if we go to the other composition, I'm going to go g, and f function is 2a minus 5. So now everywhere I see an a in the g function, I'm going to substitute the 2a minus 5. And if I distribute, I get my answer. So I have my answer of this function substituted, I have my answer of this function substituted, doing compositions.